Welcome back, and thanks for joining in again. This will be our part two, what will most likely be a three-part series on linear equations. If you missed part one, I will probably at some point put in a little box somewhere around here that will hyperlink back, or you can just hit the playlist and access part one if you missed out. So at this point, we are going to get into the method behind the madness. How do we solve these equations? Now, I have included a plethora of examples, so I'm going to do most likely one or two and leave the other blank for you to practice on your own. If you are one of my students, you will have additional resources, and I'm sure there's plenty of books out there. I prefer this one. Okay, this is an older edition, I think 2014. But that is my personal preference. Just from a mathematics perspective, I like how it's written, and I like the way that it is structured. So if you are on the market, I guess, looking for a practice and review, I totally recommend Kaplan's series. But let's get back into the mathematics. Okay, so if we were to look at 3a, okay, right, a lot of times mathematics as we do it, it's silent. Right, we read this, but I can't tell actually what's happening inside of your mind, and vice versa. So essentially what we want to ask ourselves is, what is happening to the variable? So if I would read letter A in English, right, I would read it as x minus 5 equals 9. Notice we use the word minus, so there is a value of 5 being subtracted from the variable. So in order to solve this equation, I want to apply the opposite, or how we define the inverse, to essentially move the 5 from one side of the equation to the left. Let me undo that. Sloppy. Plus, that's still sloppy. Right, and we're going to form a pretty bad habit here, but I want to reiterate the reason why I'm able to cross out the minus 5 plus 5 is because if we do that calculation, we'll wind up at a value of 0. Okay, so what I'm doing is from part one, like we had said, right, I am adding a value, as we see here, right, the additional property of equality on both sides of the equation. I'm adding 5 to both sides of the equation. Just conveniently enough, by doing it on the left side, it's going to leave me with just my variable, x. And this pen is not cooperating right now. Apologies. Right, and then 9 plus 5 will yield a value of 14. Okay, and yeah, I know. Very straightforward. Okay, we call these one-step equations, right? We applied one step and we arrived at a solution. Okay, and remember the key word here that we want to reiterate is the inverse or opposite. I have this terrible habit of using much richer language. So let's take a look at C, because this is typically one that will freak most people out. But once again, we need to be able to read it in English. So if I were to read this, another bad habit, we'll read it as T over 6. Okay, over is not an operation. T divided by 6 would be much more effective, equals 30. Notice the variable T is being divided numerically by 6. So if I wanted to apply the inverse or the opposite operation, I would multiply both sides of the equation, right? Because we want to treat equality, right? Whatever we do to one side, we got to do the other, right? Treat others how you'd like to be treated. So if you're going to treat one side of the equation a certain way, you must treat the other, because that's not nice, and we're nice people. I mean, I hope. So as we can see here, right, on the left side of the equation, right, we'll ultimately wind up with, I'm not going to write it in the next line, but 6 times t, that's 6t divided by 6, okay? And as you gain more efficiency here, right, you're most likely going to do this, okay? But remember, the reason why you're allowed to do that is very similar to letter A. Now, letter A, they cancel out, right? They become a 0. But when we divide, 6 divided by 6 is going to yield a 1. So we'll be left with T, okay? In both instances, the variable becomes isolated. And 30 times 6, last time I checked, was 180. Okay, and utilizing from part 1, right, we could go back, substitute, and make sure that these solutions are valid answers. Okay, let's proceed. Scholar level concept. Remember, the properties that we are using to solve equations don't say that you can do anything. Now you want to cooperate. You want to both sides of an equation. These properties say that you can, yep, you got it, add, subtract, multiply, and divide. Right, these are the operations. By the same number on both sides, and I want to reiterate, so I will circle it in neon green. Both sides, okay? Equality. Do not be a mathematical meanie, okay? And treat both sides not equal, okay? Let's delve a little deeper into a little bit more complexity. So notice, right, we start to have more values and terms as part of the equation. So let's take a look at B. C is missing a value. Okay, make it up, put a number. Then you can create a billion different equations. But let's take a look at B. Okay, so how do we attack this? Okay, notice we have I'm going to underline my variables, and I'm going to circle my constants. Okay. Constants and variables, not really fans of each other. So essentially what we want to do is we want to put our variables on one side of the equation and our constants on the other. Now, this situation, drop my pen. I like it because there are 4 different options. Okay. Now, preferably, this is how I operate. I like to put my variables on the left side. I don't know. I just like saying x equals this instead of 4 equals x. Just a habit. If it's no difference to you, okay. I think it also depends too on whether or not I can foresee symbols or terms becoming negative and things of that nature. The more I can keep things positive, the more I will. But I'm going to try and move this 4x to the left side of the equation. Okay. Notice it is currently positive, so I want to. That does not look like a positive sign. So I'm just going to subtract. Come on. Not working with me again. Oh, my pen turned off. That's why. Be helpful. There we go. Right. 4x minus 4x, right? If we take away 4x's from 4x's, that becomes a 0. But I am not a mathist, racist. I am in favor of equality for all, so I'll make sure I do this to the left side as well. And notice the right side of the equation now just has a -8, right? Just numerical value. There are no longer any variables on that side, okay? So I call this effect, let me draw a better arrow. And if you're a student of mine, you should know what's coming next. I call it the windshield wiper, right? Because we brought a term this way, and just like a windshield wiper when it's raining, we will now return, okay, with another term. Now, what term is that? Well, notice it makes no sense to bring over the variable So we should obviously bring over the number, right? Especially considering that there's a negative 8 there. So we want to consider the opposite operation, right? If I were to read this 2x minus 10, so I'm subtracting 10 from the variable expression. So I'd want to do the opposite, which is add 10 to both sides, okay? Running out of space, okay? So the next line of our equation, we'll say 2x equals negative 8 plus 10, okay? You'll probably instinctively reach for that calculator. Do not. Challenge your brain and try and strengthen those synapses inside. Negative 8 plus 10, right? Negative 8 is a negative value, but 10 is positive and greater, so there'll be a difference of 2. Okay, and then last but not least, okay, bad habit 2x, like I reiterated previously, that was really 2 times x. So I would want to, in this instance, divide by 2 to isolate the variable. Once again, making sure I do it on both sides and arriving at x equals 1. Okay. I am going to finish up with the helpful hint and then come back for the monster equations because they're a little bit more intense. Okay. I'm actually going to type in my text here. Might be a little bit better. A great strategy for solving linear equations is to rearrange all terms with a variable on one side and all terms without. Can I drag this? Oh, I can't look at that. Without the variable on the other. Then combine your like terms. Okay. And if you're watching these videos and you haven't really worked with polynomial expressions yet, it's going to definitely feel difficult and foreign and unknown. But give us some time, and I promise it will get much more simpler. So combine our like terms, multiply or divide to isolate the variable, thus leaving yourself with an equation with an obvious vocab word solution. Cool. Let's pop that there. And let's get rid of that text box. Okay, so that'll do it for part 2. All right. I hope you enjoyed. Once again, if you have any feedback or any comments, please leave them below or send me an email. And I see you very shortly for part 3.